Okay, so this is the fifth and last part of chapter 9, hypothesis test for proportions. One thing is very simple in proportions, we always use z test, irrespective of sigma given or not. We need to be careful to decide which test we need to use between z or t when we are not dealing with proportion. But when we deal with proportion, we always use we always use z test. So here again the formula for proportion is exactly same which we did in chapter 7 and chapter 8, x over n. So the number in categories of interest in sample, and n is the sample size. So this pi is population proportion and sigma p is pi 1 minus pi over n. And here z statistics, the formula for z stats takes this form: p is sample proportion, pi is population proportion divided by sigma p. Sigma p equals to square root of pi times 1 minus pi over n. So you can write the statistics formula in this form as well if you want to, otherwise no need. We solve an example. A marketing company claims that it receives 8%. One more thing, we always use proportion when you are given results in terms of percentages, or you are given any particular characteristics, like before, if there is a class, how many girls, how many boys. So we are talking about any particular gender. So x is a gender in which we are interested, gender of interest, and n total number of students. So p will be, let's say, x over m. So a marketing company claims that it receives 8% responses from its mailing. To test this claim, a random sample of 500 n is 500 with 5 responses, surveyed with 25 responses. So p is 25 over 500. So n is 500 out of 500, responses are 25. So x is 25. And this is our pi population proportion. Everything is exactly same. We define null and alternate hypothesis. The claim was it is pi is 0.08 and alternative is pi point not 0.08, alpha is 0.05 and n is 500. So p is 0.05, like 25 over 500 is 0.05. So critical value, we calculate these statistics, use this formula. You are given p 0.05, pi 0.08, and here you will substitute pi and you can get z statistics. Likewise, you can get z critical, and for 0.05 z alpha by 2 is 1.96, because it is two-tailed, so that is why it is 1 alpha by 2. And again, following the same rule to accept or reject the claim, we can follow reject h naught. In case of two-tail, we put absolute value, doesn't matter negative or positive. Z stats mod if it is greater than z critical. So this is how we can take the decision. So reject h naught because c statistics is greater than z critical. So here you can write it in this way to calculate the p-value. So z is minus 2.47. So in the z table you will see corresponding to minus 2.47, you will see where it lies. Sorry, minus 2.4, and here you will see 0.07, and that would be your 0.006. 0.68. Since it is alpha by 2, so you will add this one and this one. That would be your p-value in case of z-test, as we already did before. This is just to practice, and you can take the decision on the basis of p-value as well. If p-value is greater than alpha, we reject this not.